Welcome to On-Ramp, on our way to MBA 643. I am Dr. Danielle Morin, and this is Module 4, Descriptive Statistics, Measures of Locations. We will study in this module and the following two descriptive statistics. For this module, we'll look at measures of location. Measures of location are often called measures of central tendency. Measures of central tendency are parameters or statistics giving information about the values at the center or the middle part of a data set. We will see 4 of those measures. The mean, commonly known as the average. The median, commonly known as the middle value. The mode, also known as the most frequent value. And the geometric mean, which is the tool that is often used in finance. So the mean we start with is simply the arithmetic mean. But commonly we call it the mean, but it is not the only one. There are other types of means. So this concept is applicable for interval and ratio data, but not to nominal and ordinal. So the mean is computed by summing all the values in the data and dividing by the sum of the number of value in the data set. We decide, do we use X bar or mu? We remember that if we have a sample, we are using the statistics X bar. So xi correspond to the observation I. Observations do not need to be in order to be able to calculate the average. If I have the population, it's exactly the same approach, the same calculation, but the name is different, and I will call it mu, the Greek letter. So the calculations are the same. So let us take an example. What is the average age of the 20 randomly selected people who went to see a movie last Sunday afternoon at Cineplex? These are the observations that we have seen in the previous section. I simply add them up, 24 plus 35 plus 17 all the way to the last value, 27, and I have 20 observations. This is 32.45. All our calculators can easily get you X bar, but it's rare that you need to do it manually. We'll use Excel to do that, but nevertheless we should know how to do it. In Excel, it's simply average, and you put the sequence of observation that you need to calculate the mean for. Excel doesn't mind if it is a population or sample data. It doesn't make a difference for the calculations. The mean is sensitive. What does it mean? So let me take a first sample, observation 1, 2, 3, 4, and 5. I calculate the average. I call it X bar 1 because it corresponds to my sample 1. 1 plus 2 plus 3 plus 4 plus 5 divided by 5 observation, it gives me 3. My second sample, suppose I made a typo. Instead of 5, I've added the 0. Is it going to change my calculation? Of course it will. So it did have a big impact. So extreme values or errors, extremely small or extremely big value, will have an impact. And for that reason, we say that the mean is sensitive to extreme values. The median, on the other hand, is the center value or the middle value that divides my sample into 2 equal parts. Well, of course, we have to do approximation. Sometimes the middle is between 2 values. The trick about it is just get your data in increasing order and find the rank of that value. So the rank will be number of observation plus 1 and divide by 2. We know very well that n plus 1 could be an integer when I divide by 2 or not. So if n plus 1 over 2 is an integer, then the median corresponds to the observation with that rank. But if n plus 1 over 2 falls between 2 integers, maybe 9.5, then the median would be the average between the 9th and the 10th observation. Remember, this is only the rank. It is not the median. Often people confuse this. This is not my median. It is only the rank. Let's take the median age of those 20 randomly selected people who went to see the movie on Sunday afternoon. We'll sort this observation. We know we have 20 data points, so let's calculate the rank. The formula, 20 plus 1 divided by 2, it's 10.5. Well, the rank is not an integer, so it says that it will be the average between the 10th and the 11th observation. Is my 10th observation, is my 11th, so the average between the two, my median, is 31.5. Somewhere in between, I have 10 observations before and 10 observations after. This is the reason why the median sometimes falls between two numbers. The median is not sensitive to extreme value like the mean was. So let us take my first sample. What's the median? It's already in increasing order, so the median is the third observation. Similarly, on this one, it is still the third observation, even if that last observation is 50 instead of 5. Even if it was 5 million instead of 5, the median will be the same. We conclude that the median is not sensitive to extreme value, which is good. So the median applies for ordinal, interval, and ratio data. Ordinal is if I have a progression from very weak, not weak, so then there is some kind of order and I can see what is in the middle. Interval and ratio data. The advantage of the median, it's not affected by extremely large or extremely small observation. But the disadvantage, it's not using all the information. Like it did not capture that the last data point was a mistake, was too large. So we saw the mean, the median, and the other one is the mode. The mode is the most frequent observation. Well, there's no calculation required, but you still need to put the data in increasing order to identify repetition. Sometimes there are no modes when no observation is more frequent than the other. Like 1, 2, 3, 4, 5, there's no number that is repeated, nothing is more common. Sometimes we could have more than one mode. Suppose there is a tie between the two most frequent observations. In this case, if I have one mode, I call it unimodal. If I have two modes, it's bimodal. If I have more than two modes, it's multimodal. Let us take an example, and of course not sensitive to extreme value. And the mode applied to all the level of measurements, including nominal. For example, I have the proportion of people with blonde hair, black hair, and brown hair. And the population with the brown hair is at 60%, which is higher than the other. Then the brown hair category would be the mode. So let us find the modal age of those 30 selected people who went to see the movie last Sunday. I have to look in increasing order. I sort them. And now, are there any repetitions? Well, I see that 24 is repeated, and I see 27, and I have no other repetitions. 24 is the most frequent, and 27 is also frequent. So in this case, I have two modes. It is a bimodal distribution. Easy to see. If I have 20 observations, it is easy to do. But if I have 500 observations, it's going to be long to identify all those statistics. So this is how the printout in Excel will look like. So it will give me the mean. So we saw 32.45. It will give me the median. It gives me the mode. But you see something here. When statistics given by Excel will give us the first observation that is being repeated as the mode. But we know well there is a second mode. So we would have to use more detailed statistics to find that. It's giving me the range, the minimum, the maximum, the sum of the observation, and the count, which is my n, the number of observations. So all these things can be done easily in Excel. Suppose I have the following situation. A sample of 5 properties has been randomly selected and their selling price recorded. If your friend is asking you what house price should he anticipate in that neighborhood, what descriptive statistics would you use? The mean, the median, or the mode? I look at my observation here. What would be the best way to describe the price of the house in that neighborhood? Well, will you tell, well, there are $2 million house and be ready, but there are cheaper houses. So let's calculate the mean. So the mean, 2 million plus 300,000 and so on, divide by 5 give me that the average price of the house is 600,000. Is there something wrong with this? Of the 5 houses that I have considered, all of them cost less than 600,000. So this is a very misleading information for your friend. You would think that all the houses are in that neighborhood. It doesn't work this way. So maybe the mean is a little bit misleading. And we see why. Because in this mean, this big number here is considered an extreme value. So it has pulled the mean up. The next one is the median. So let us order the numbers and see what would be the median. So the element in the middle is 300,000. So 300,000. If I want to follow my formula, it is n plus 1 divided by 2. So 5 plus 1, 6 divided by 2 is 3. So that's the third observation. And the mode is the most frequent observation, 100,000, 100,000. So what is our answer? What statistics would best describe the situation in here? Well, probably for your friend, you should mention that the median is 300,000. So he will expect 50% of the houses cost more than 300, but 50% of the houses cost less than 300. It's probably a better estimate of the situation. If you give him the mean of 600,000, he will think that never he will be able to afford the house because he expects to pay much less than that. And the mode just gives us the indication that there are many houses that are cheaper. On a small sample like that, we cannot really appreciate the value of these statistics. In general, we will specify the mean and the median. When we report information, it's good to give both. For this one, the mean is not a good statistics and the mode is not, but the median might be the one that is most interesting. Another statistics that is used, but mainly in finance, it's called the geometric mean. The geometric mean is, instead of adding the observation, I multiply them together and I take the nth root. Basically, I raise this to the power 1 over n. You cannot calculate that if your calculator does not give you the nth root. So let's see how it would work. Consider the percentage annual return and growth factor for the mutual fund data over the past 10 years. What is the mean rate of growth for the fund over the 10 years period? So we're looking at the growth here. I will need to calculate this geometric mean for the growth. So how will we do that? Remember, this is my formula. I have 10 observation, n is equal to 10. I start multiplying. 0.779 multiplied by 1.287 times 1.109 and so on until 1.021. And I raise this to the power 1 over 10. I do my calculation and I find it is 1.029275. That means, what does it mean if I have this? The annual return grew at an average annual rate of 2.9%. So overall, sometimes it went up, sometimes it went down, but at the end, it's a rate, average rate of this. Now, of course, you don't want to have to calculate that too often, but the geometric mean is a command in Excel, geomean, of the array of data that we need. There are more measures of locations that we should look at. Well, there are the percentiles and the quartiles. The percentiles will divide my population into parts. They are still measure of central tendency and they divide a group of data into 100 points. The nth percentile is the value with at least n% of the data below that number, and the rest above that number. For example, the median is the 50th percentile, which tell me percentile, 50 percentile, 50% under, and 50% above. So the percentile method is applied to ordinal, interval, and ratio data, but not to nominal. And in general, the percentiles are not influenced by extreme value in the data set. So let's look. So there are many ways to approximate the percentile. It's difficult to exact. We still look for the rank, but it is very difficult or not easy to get the value. So we will use the approach of Excel to avoid possible confusion. I am sure some of you have seen already how to calculate percentile. You might have been using all different formulas. So to avoid confusion, I propose that we use the formula used in Excel, and it is also the formula that will be adopted in our book in MBA 643. So we sort my data in increasing order, and I have to identify the rank. The function that we will use, this is percentiles.exc function in Excel. What it does, that formula takes the rank of the percentile will be at the point P. P is the proportion that I want, the percentile that I want, times n plus 1 divided by 100. And the number that I will get, I will divide it in two parts, an integer part and the decimal part. See that? P is the required percentile, and the number of values. I, the integer part of the ranking, and D, the decimal part of the ranking. So percentiles.x is used by Excel also to build the box plot that we will see later. Let us take an example to clarify this. I still have my 20 selected people who went to see a movie last Sunday afternoon. What is the 60th percentile? So I want to divide my observation. 60% will be under me, that number, and 40% above. I need to put the data in increasing order. I'm looking for the rank. Because I will use the approach of Excel and the approach of our textbook, the rank is P times n plus 1 over 100 is equal I plus D. P is 60, so 60 over 100 times 20 plus 1 is 12.6. 12.6, I will split it in two parts, the integer part and the decimal part. The integer part is 12. I'm looking for the 12th observation. Where is my 12th observation? 1, 2, 3, 4, 5, 6, 7, 8. And here is my 12th observation, which is 35. Therefore, my percentile, 60th percentile, will be 35 plus 0.6. This is the interpolation of the next value between my 35th, my 12th observation and my 13th observation. So 0.6 times the difference between the two, 37 minus 35. That will give me the between those two numbers, and that will give me a 60th percentile as 36.2. Of course, if you have learned about this before, you might have a different way of calculating, but I'm using the interpolation approach of Excel so that we all have the same answer. Often we will work with, in the paper, we will give you the quarterly results. So we need to find the quartile, divide my observation into 4 parts. The first 25%, next 25%, so a total of 50, which is my median. I call it Q2, second quartile. The third quartile will have 75% of the observation under it and 25% above. So my first quartile, Q1, is P25. My second quartile, Q2, is P50. And my third quartile is P75. Let us practice that. I look again at the age of those people who went to see that movie. It must have been a good movie. because we keep coming back to it. What are the quartiles? I need my Q1. First quartile corresponds to P25. So we go for the rank 25 over 100 times 20 plus 1, it's 5.25, which is 5, fifth observation, and plus 25, the difference between the other two. So my fifth observation is right here at 24. And then I take 0.25 times 24 and its next observation. Another 24. So in this case, 24 minus 24 is 0. So my quartile is, first quartile is 24. So again, I have used the formula percentile.exc. Let us do the second quartile. Second quartile corresponds to my median, P50. 50 times 20 plus 1 gives, divided by 100, it's 10.5. So it's the 10th observation. Look at the 10th observation plus 0.5, the difference between the 10th and the 11th observation. So here's my 10th observation, 31, plus 0.5, the observation that comes, the difference between the 10th and the 11th observation, times 0.5. So it gives me a quartile here. My second quartile, or the median, is 31.5. And then the third quartile, similarly, I take my rank, so 75 times 20 plus 1 gives me 15.75. So it's 15 plus 0.75. I guess by now you guessed it, I need my 15th observation. So where is my 15th observation? It corresponds to this 41 here. Plus 0.75, the difference between this observation, 15 and 16. So we have here 41 and 42 and 43. So 0.75 times 43 minus 41, it's 42.5. So important, at this case here, we have used percentile.exc. If I had used inc instead, percentile.inc that is suggested, it will give me a different answer. So to be consistent, once again with the book, this is the approach we will take. So this Excel interpolates between the values. Many people don't like to interpolate, but this is how Excel does it. So between values, and percentile.inc will give the smallest value for the percentile. We don't use this one. We will use instead percentile.x, which gives me the largest value for percentile. Since all those methods are only approximation, when we have a large data set, we have to rely on Excel to be consistent with the textbook. So let us go now on Excel and reproduce some of those calculations. Let us apply in Excel the calculations that we have done during our module 4. If I go to data, data analysis, I will ask for descriptive statistics. Descriptive statistics of the data that is in A1 to A20. No labels were selected because I don't use title. And I will ask for the summary statistics. So here was what we have. We have the mean, we have the median, we have the mode, the range, minimum, maximum, and the count, the number of observations. So this part is easily done. We also looked at the fact that mode in Excel is going to give me the first time there is a mode. If there is another mode of equal frequency, it will give me the first one. How to calculate the percentile? So let us start with equal percentile, and we choose the first one, .exc. I will have to choose the array that I need, comma, and if I want to have my first quartile, 0.25. as we found before. If I want to find the 60th percentile, equal, again, percentile x, the array is here, comma 0.6. Excel has selected the information that we need when we ask them with percentile.exe. Makes it easy to understand. So I can get the quartiles from this formula, and we can see it in the dialog box here. So therefore, all these information can be obtained easily in Excel. I did not need to put my data in order. Excel will have done it for us. Voila. In Module 4, we have looked at measure of central tendency, or in general, measure of location. It is time now to solve some questions. So you either do them manually or with the help of Excel. So we'll see you at the next module. Bye.